All right, today we will be talking about Introduction to Descriptive Statistics. Hopefully this is a review for some of you, and if not, doesn't really matter, we're going to get started anyway. So first of all, this is what we'll be talking about today. What are descriptive statistics? They are numerical values, quantitative usually, again, numbers used to describe your sample and also used to explain your findings. They are typically expressed in counts or ends, or also frequencies, percents, proportions. And then there are a few measures of central tendency that we'll discuss as well: mean, median, mode, and range. So first of all, to use descriptives to explain your sample, you might be thinking about demographic data. Demographic data can describe human populations, also settings such as, of course, schools, districts, cities, or communities or other. And I encourage you to look at figure 3.1 in Bernhardt. That is a really explicit or detailed table of different kinds of descriptive statistics that you might want to use. And here's another kind of pull out from the Bernhardt chapter, just about different kinds of descriptive statistics that you might be interested. So you might start with numbers of the number of students in the school, and then you might go to number of students with special needs, a number of students who are learning English as a second language, and maybe you even break those groups down even further. So that gets us to disaggregating data. When you think about disaggregating data, you're going to think about your subgroups. So again, think of the number of students in the school. Maybe you're interested in something that's broken down by grade, and maybe you're interested in gender or free reduced lunch eligibility. We often use that as a measure for low income status or socioeconomic status, right? So maybe you're interested in all of these figures broken down by these different subgroups. So here's a table to go over this as an example. If we have 500 students in the school, you can see the number, or again, the N, the count of students in each grade, first through fifth. Apparently this school does not have kindergarten. And then we can see the number of boys and girls in each grade, the number of students in each grade that are eligible for free or reduced lunch, and the number of boys and girls in each grade that are also eligible for free or reduced lunch. So as we move down the chart, those numbers represent kind of different groups of those different breakdowns. So what happens if we include percents here? So that first kind of chunk, that first line is, if we look at the first grade, again, we have 112 students in first grade, which represents 22% of the whole school. And moving across that row, you can see, again, the majority of grades, they hover around 20%. First grade is the biggest, third and fifth grade is the smallest in terms of proportion of the whole school, being at 19%. So now if we look at the line under that, we can see in first grade, we have 56 boys and 56 girls out of 112. Of course, that means it's 50-50. That's not the case for each grade. And you can see that if you, again, move down that row. So just to be clear, this is 50% boys and 50% girls per the grade, right? This is not necessarily 50% boys and 50% girls out of the whole school. So again, we're looking at just first grade there. For the next line down, we have 76 students in first grade who are eligible for free or reduced lunch. And here we have 15%. So this is actually representing the proportion of students eligible for free or reduced lunch out of the whole school that are in first grade. So you might say 76 students, or 15% of the school, is eligible for free or reduced lunch if they're in first grade, something like that. So you can see how the denominator changes, right? The row up above, the denominator was first grade, total students in first grade. And for if we're still looking within that first grade column, the 76 students and 15%, that 15% represents 76 students out of 500. So again, out of the total school. And if we look at the row below that, we see that 37 boys, or 49% of boys within first grade, are eligible for free reduced lunch. So that denominator there is actually out of 56. So we have 56 boys, 37 of them are eligible for free reduced lunch. So again, that denominator changes, right? It's not out of 500 for the school, and it's not even out of 112 for first grade. So this is an example of how when you disaggregate, right, you need to think about who your total group is, your base group, and also think about what makes sense to present here. Do numbers make sense? Do proportions or percents make sense in terms of what you want to be telling your audience, right? What story you want to tell with your data. Okay, so just one more note on this table. This is a little bit busy. I would not recommend including numbers and percents in the same cell as it's presented here if you were going to put this in your dissertation or in a paper. I would also not recommend changing the denominator in the same table. So for example, if you want to look at within first grade only, that might be another table. If you that might be table 1, and if you want to look at free reduced lunch out of the entire school, that might be a second table. So think about too, not only what makes sense for your data and telling your story, but what makes sense for the reader and what might be most intuitive and easy to interpret for them. So to drive this this point home just a little bit further, I have another example here. And in this slide, we're going to kind of talk about what is more important or more telling to present. Again, the N or the count or the percent. So here we have a rather large high school. It has 3,860 students. That's a whole campus population. And we are interested in how many students in this school saw their school counselor during drop-in hours. So out of the entire school, we have 151 students who saw their counselor during drop-in hours, and that's 3.9%. So you might say, overall, that's not a very large proportion of the campus. Maybe this is not super effective. But if you are interested in specifically reaching your senior students, right, maybe they're the ones who need the most help with college applications or financial aid or questions about graduation or college, anything like that. Well, 131 of the students of seniors did go and see their school counselor. So we have 1,232 seniors and 131 of them saw their school counselor. So if proportionally, we could say, well, that is 10.6% of the senior class. Okay, maybe that's not so bad. And it's definitely a larger proportion of the population than certainly 151 students of the entire campus. So if we look at the third line down, we might be specifically interested in students who are in the STEM learning community and whether or not students in the STEM learning community go and see their school counselor. So out of all students in the STEM learning community, 95 students saw their school counselor. So we have 95 students out of 1,372, because that's how many are in the STEM learning community. And now we're approaching about 7% of the campus population. So again, if we are specifically interested in getting students in the STEM learning community to see their school counselor during drop-in hours, about 7%, I'm not sure if that's so great. But the next line down, we have 370 seniors who are also in the STEM learning community, and we've reached 71 of those students. Now here, we've reached over 19% of that population, right? So we're looking at who again? We're looking at 370 seniors who are also in the STEM learning community. And the line below that is how many seniors in the STEM learning community are women, right, or female students. So we have 56 women seniors who are also in the STEM learning community. And there we're reaching 23%, more than 23% of that population. So this is just an example of, if you're looking at 56 women who are seniors in the STEM learning community, and that's the number out of the whole campus population, again, we're going to see that's what, maybe 1 or 2% of the whole campus. But if we're specifically looking at a more targeted population of women who are seniors and who are in that STEM learning community, then we're actually reaching close to a quarter of that population. And so depending on what story you want to tell, the N or the counts, and most likely both, are going to help you tell your story. So now we're moving into a discussion about descriptive statistics, and this can help you explain your findings. Again, the last table that we just saw is also an example of explaining your findings if you're interested in that sort of research question, if you will. But here, most of us are maybe familiar with the mean, which is also called the average. To calculate the mean, you have the total number of scores, or the total scores as you have summed them, as you have added them up, divided by the total number of scores. So again, we can see 45 plus 47 plus 41. We have 3 scores there. 133 divided by 3 scores. Your average is 44.3. One thing to keep in mind here is if you have 3 students and you have a 4th student who has scored extremely high or extremely low, that can skew your findings. So for example, an average of 44 makes sense for the first example, right? 41, 45, 47, 44, that seems to capture generally what that group of students has done. However, if you include a super high score of 78, we are now at a sum of 211 divided by 4 scores, and the average score has actually jumped up to 52.75, and that seems a little bit higher than kind of what most students or what the average is for that group. So just keep that in mind when you're considering presenting a mean to explain your sample. We also have a median. A median is another way to explain your data. And this is, it's the middle point of your data. So if you arrange your scores in order, from the original example, we had 45, 47, and 41, but we actually need that to be 41, 45, and 47. 45 is the middle number. You have the same number of scores on the left and of the right of the median, so the median is 45. If you have an even number of scores, you take an average or the mean of the middle scores. So let's say that we had 41, 45, 47, and 48. The median is the average of those middle 2 scores. So 45 plus 47, again, divided by 2, your median is 46. And then we have the mode. The mode is the most frequent score. So if we have 3 scores and there are no duplicates, no overlapping scores, then there is no mode. But if we have a data set as the one below that has 41, 45, 47, 48, 50, 41, 46, and 41, we can easily see that the mode is 41. So something to think about here is when you might want to use the mean, median, and mode. The mode, you're thinking about the most frequent score. Well, if you're thinking about, let's say, maybe class grades, you might want to know the average grade, but you might also want to know the one that was scored most frequently, right? Again, considering that 1 or 2 high scores or low scores can skew your average, maybe the most common score is important. You could also see that the median score might be important there. If you have an equal number of students scoring above and below, let's say a B minus, what does that say about your learning outcomes, your grading structure, the rubrics you use? Those kinds of questions are what you can ask as a practitioner, right? And then we also have the range. These are the high and low scores of your data set. So again, in this example, the range is 41 through 50. That's one way to say it. You can also say that there's a range of 7. Nope, sorry, that would be a range of 9. You can just ignore that on the slide there. 50 minus 41 is 9, right? So you could have a range of 9, or you can say the range is 41 through 50. Both are appropriate. I think the range of 41 through 50 is a little bit clearer because it explicitly states exactly what the high score and the low score are. If you say range of, you have a range of 7 or a range of 9 as whatever might be written on your slide, that tells you how wide the range is, but it doesn't tell you the high and low, right? So you could easily see a range of between 201 and 210, you would still have a range of 9, right? But here, compared to our scores, that's a much different data set that we have. So that's just something to think about as well. Just a couple more notes here on when you might use mean, median, mode. Again, average test scores are often really commonly presented. In my work, I think a lot about how many units per semester students are enrolled in, right, at the different Cal State campuses. And so whereas average is really important, we want to know if the average student is taking more than 15, because 15 units helps you progress to graduation on time. But we're also interested in the average, right? So, or I'm sorry, the mode, right? So if most students are taking, let's say 17 units, but the average is about 14, on average, we're sort of below progress in terms of, we know, again, 15 gets us more quickly to graduation. But if most students are taking above 15, then we might not need to spend a lot of energy in that campaign. Or we might want to target specific students that we know are not enrolling in 15 units or more, right? But it might not make sense if, again, most students are taking 17 units per semester. It might not make sense to put a whole lot of effort into a campus-wide campaign to increase the number of units taken per term. All right, so that's just one way of using two data points, again, the median and the mode, to further create your argument or make your case. So here is just one more point that I want to point out here, and this is the difference between percentage point change and percent change. So here is a graph about Graduation Initiative 2025, which is the system-wide goal to increase graduation rates. This is a lot of my work, so I'm bringing in my real-life examples to this class. So you can see that over time we have increased from 57% to 62% to 70% in terms of first-time students graduating within 6 years. And so the percentage point change is the difference between 70% and 62%. So that is an 8 percentage point increase from our 2020 rate to where our goal is. Or another way to say that, right, is from 2015, we have increased from 57% to 62%, or 5 percentage points. That's a way to say that. However, this is not the same as an 8% gain or an 8% change. Percentage points and percents are different. And I just want you to know that, so that when you're thinking about it and talking about it and writing about it, you write about it correctly. Again, 62% to 70% is an 8 percentage point gain. So percentages are numbers or ratios as a fraction of 100. And then here, what to think about percent change, you actually have to consider the two scores, and there's a little bit of a formula here. So to calculate percent change, you take that time 2 minus time 1 divided by the absolute value of time 1. So again, you can see the percentage point change between 62% and our goal of 70% is 8 percentage points, but the percent change would need to be 12.9% if we were to reach our goal. So you don't necessarily need to remember the formula for calculating percent change, but I do want you to be able to use the language of percentage point difference, right? If, again, you're just using that simple formula of subtracting times 1, or time 1 by times 2. Again, so knowing how to say the difference between percentage point and percentage point change and percent change. And that's actually all we have for this quick refresher on descriptive statistics. So we will stop there.